Question 28. Solve the following equation. NP2 equals N choose 3. So this is a permutation / combination equation. So the first thing we're going to want to do is to write an equivalent expression for each side. So an equivalent expression to NP2, if we check with our formula sheet, we can see that our value of R is 2, and our value for N we don't know yet. So our formula tells us N factorial all over N minus R factorial, which in this case is N minus 2 factorial. So that's it for the left-hand side. The right-hand side, we need to use our combination formula. Again, this time R is 3, but we will put this in. So NC2 is N factorial, and for the combination, it's still the difference on the bottom, N minus 3 factorial. We also have to multiply by R factorial, which of course is 3 factorial. So here is our equation that we want to solve. So the first thing that I notice is we want to expand this expression. So I'm going to treat the left and right hand separately, just as I'm trying to expand the expression. So when I look at the left side, the expression I want to expand is the top because it's larger. So we all know that 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. If we are expanding n factorial, well, our first number is n, and then we want 1 before n. There's an expression for that, n minus 1. 1 before n minus 1 is n minus 2. Now I could continue to expand this, but I have an n minus 2 factorial on the bottom. So if I want to stop an expansion, you can put a factorial sign there. So what do I mean by that? Yes, 6 factorial is 6 times 5 times 4 times 3 times 2 times 1, but I could also write 6 factorial as 6 times 5 factorial. So I could stop it at any time as long as I put a factorial after, because that takes care of the rest of the expansion. So now I have that. And continue to work with the left side. This is what I wanted to get, some type of cancellation. So on the left-hand side, I have n outside of n minus 1. Now I'm going to go revisit the right side. Again, I'm going to expand the larger of the two. So the larger of the two are n is bigger than n minus 3. So in a similar way, I got n times n minus 1 times n minus 2. I can't stop yet because I got an n minus 3 on the bottom. So n minus 3 factorial. Now I can stop by writing the factorial symbol after. I have n minus 3 factorial times 3 factorial. So we get a nice cancellation here as well. And we get that expression. So what do we have? What are we bringing forward? We're bringing forward n times n minus 1 times n minus 2 all over 3 factorial. Okay, so now we can see this as an entire equation, and we could have did this earlier. I'm just choosing to do it now. So I could divide both sides because I have the restriction for this problem. I know n has to be greater and equal to 3, because if we're choosing 3 objects, we can't have fewer than 3 objects to start with. So I could divide both sides by n, and that would essentially cancel the n's, and that's fine because n is not 0. I could divide both sides by n minus 1, and then I get that following expression. So what I'm left with on the left-hand side is 1, because I am kind of dividing by n. And let me make that clear. I'm dividing this by n outside of n minus 1, and I'm dividing this by n outside of n minus 1, right? So that's why it goes. So I'm left with a 1 on the left-hand side, and that equals n minus 2 all over 3 factorial. 3 factorial is 3 times 2 times 1, which is 6. Now I'm just going to cross multiply. 6 times 1 is 6. 6 equals n minus 2. So what number? Subtract 2 is 6, and would have to be 8. So if we double check, n equal to 8 fits our initial restriction where n is greater than or equal to 3. So that looks like a good answer. So we know the answer is n equals 8.